All right, standard 9E is empirical formula. The most general way you're going to be asked about an empirical formula is just to reduce a given formula to its lowest terms, which we already do when we write ionic formulas, when we crisscross the charges. So for example, C6H12O6. If I asked you to write the empirical formula for that, the ratio is 6 to 12 to 6. That can be reduced, right? So if I reduce it and put those ratios in their lowest terms, it becomes CH2O. So I would divide each one by 6. The ratio is still the same. There's twice as many hydrogens as the other two, but that's what the general way to form an empirical formula. Be on the lookout for things like C3H3O. Okay, that may be a molecular formula, which is on this side over here, but it's also an empirical formula because it cannot be reduced anymore. You have to be able to reduce all of them, and because there's a 1 with that oxygen, you can't. So that's a case where it's a molecular formula as well as an empirical formula. Another example would be C2H6. Okay, both of those are divisible by 2, and that would turn into, as an empirical formula, CH3. Okay, now that is the most common way you're going to be asked about an empirical formula, but you could also be asked about an empirical formula to get it from percentages or grams. So I always tell kids percent to mass, mass to mole, divide by small, multiply till whole. So for example, I need to have an example of this. Let's do something that's 50% sulfur and 50% oxygen. Okay, so the first step is percent to mass. When I say percent to mass, what I mean is changing those percent signs to grams. We assume we have a 100-gram sample, okay, and we just literally change the percents to grams. If you're given grams, you can skip that first step. Percent to mass, you can skip. Mass to mole is like standard 9B, where we're going to do a mole conversion. So I like to write sulfur here and oxygen here, and I've got 50 grams and 50 grams. So mass to mole, you divide each one by its molar mass. So sulfur weighs 32 according to the periodic table, and oxygen weighs 16 according to the periodic table. Here's my calculator. So this gives me 1.56 moles of sulfur, and this gives me 3.13 moles of oxygen. Okay, so we did percent to mass, mass to mole. The next step is divide by small. So I have 2 moles here. Now, these are the subscripts, right? But you've never seen anything that looks like S 1.56, O 3.13, right? We don't do that. So we need to get whole numbers. So to get whole numbers, we're going to divide by the smallest. Since 1.56 is smaller than 3.13, okay, this becomes 1 and this becomes 2. So what that means is that my empirical formula here is SO2. Okay, multiply till whole comes into play if at this stage you get 1, and let's say this wasn't 2, let's say this was like 2.5. Okay, in order to get a whole number ratio, because you can't have 2.5 oxygen atoms, you would multiply them both by 2. Okay, when you multiply them both by 2, it would become S2O5. That's not the case here, but that's multiply till whole, and that is, again, rather rare. So that's the other way to get an empirical formula.